So Snell's law. This is our big equation for refraction. And this is just the index of refraction of your first medium multiplied by the angle it's leaving the first medium, and that equals the index of refraction of the second medium times the sine of the angle. And this is really, really important. So if it says if it says something is going from air to water or air to glass or glass to water, you need to pay attention to what is the first thing and what is the second thing, because that's going to depend on where they are here, and that'll actually mess up your math. You'll get the wrong answer if you don't put them in the right place. So we'll do an example problem and you'll see what I mean. So in this problem, we're saying that a light beam hits a sheet of crown glass. So this light beam is in air. So that's our first medium. And it's hitting a sheet of crown glass. So that's our second medium. And it's hitting at an angle of 30 degrees. So we're going from air to glass. This one right here is our 30 degrees. So this is our theta 1. Okay, and then we want to know what angle is a light beam refracted, and that's theta 2. I'm going to go ahead and give you a couple of numbers. They're on your formula sheet, but I'm going to go ahead and write them here for you. The index of refraction in air is 1, and the index of refraction in crown glass is 1.52. Okay, so let's take our Snell's law equation. Okay, and let's see what we've got. Since air is our first thing, we know that this is air. So we're going to use the index of refraction of air here. This, if air is the first one, the glass must be the second one. And that's the second one right here. So we're going to use the air index of refraction here, that theta 1 that we know, and then the index of refraction for glass here, and then we're going to find the theta that we don't know. Okay, so I'm just going to go ahead and I'm going to write my formula again. Okay, and I'm going to plug in my numbers. I have 1 times sine of 30 equals 1.52 times the sine of theta 2. Okay, now I'm going to go ahead and I'm going to get this 1.52 and put them on the other side. You are more than welcome to solve it with letters first. I just decided to put the numbers in first this time. These two will cross out. Okay, and then this right here is equal to 0.33 sine theta 2. Now, in order to get theta 2 all by itself, this is not our answer. Okay, if you get a really small number like this, that means that's not the angle. Okay, so a lot of students will just put this down as their theta. They'll say theta 2 equals 0.33. No, that is wrong. Okay, do not do that. No. Okay, what you have to do in order to get theta by itself, you have to take the sine, the inverse sine, that's sine negative 1 of 0.33. Okay, if you don't know how to do this on your calculator, come to me, I will show you how to do it. Okay, but do not put 0.33 as your theta 2 because it is wrong, and I will mark it wrong, and I will sigh and be sad. Okay, now once you've done this, you'll get 19.27, I rounded, degrees equals theta 2. Do you see how this looks a little more reasonable? Okay, you're very rarely going to see an angle that is 0.33. That is really, really small. But 19.27, that's more like it. Okay, so this is your theta 2. This is your answer.